In a developing country like India, every year natural disasters bring destruction and death since the people lack the understanding of natural disasters and preparedness to fight them. In Western India, in the state of Gujarat, on January 26, 2001, the Kutchh earthquake claimed nearly 14,000 lives. It severely damaged or destroyed about 233,000 houses, while moderately damaging over 971,000 structures in cities and villages in half the state. All this was caused by the poor performance of the houses made from various materials. Here, the local building artisans, using mainly the local materials like stone, brick, mud, clay tile and timber, carry out most of the house construction. These artisans lack the knowledge of the use of earthquake-resistant construction technology. At the same time, the people also have no knowledge of the suitable building technology. Hence, for all the destruction, they blame the materials used instead of quality and technology of construction. The use of poster exhibitions, models, demonstrations, and training could help bring awareness in the masses as well as the elite. It is also possible to build confidence with the help of a comparative test between different types of buildings constructed on a shake table.
The program of testing these masonry models in the shake table is basically to build confidence amongst the people in various technologies of construction, and also to tell the people that whatever construction methods they were using, if they just improve them in accordance with the Indian standard guidelines and codes of practice, then the same technologies can become earthquake safe.
We are trying to reach the whole community through this type of visual demonstration.
The setup for this test consisted of a 6-meter by 3.5-meter RCC platform constructed on rollers that could move back and forth when subjected to shocks from a tractor. The intensity of the shocks on the structures was measured with the help of accelerometers and a computerized recorder. Because most traditional buildings have suffered extensive damage, the people are abandoning the local materials like stone and clay tiles. Since after the earthquake, they are aspiring for RCC frame structure with columns, beams and brick filler walls with RCC slab roof. These options are expensive and climatically unsuitable. A shake table test was conducted to see the effect of earthquake on traditional and quake-resistant stone houses.
This particular house to my right is a traditional house of this area with walls made of stone and cement mortar. The roof consists of Bangalore pattern clay tiles supported on the timber understructure. The second house on my right is an improved house for enhanced earthquake resistance. This house looks identical to the traditional house, but the walls, which are made of stone in cement mortar, have bond stones or the through stones, one in every 10 square feet of wall. All the walls have been built at the same time for the improved wall-to-wall connection. In addition, every corner has a vertical steel bar incorporated in the construction. At the eave level, there is a reinforced cement concrete band consisting of 2 bars, which is placed on all the walls. The lintel is connected to this band with the help of vertical bars extended from the lintel. There is a similar band at the top of the eave. It's a triangular band integrally connected to the eave band. The roofing consists of Bangalore pattern clay tiles, once again supported on timber structure. To improve the earthquake resistance, there are diagonal wires installed under the understructure, and at the eave level, in order to prevent the tiles from getting disturbed, there is an anchor using GI wires. The load walls on the top of the gable walls has also been anchored to the eave band at the bottom with the help of a bar which is extended from the eave band and is incorporated inside the load wall.
Upon subjecting the models to a few shocks with a tractor, the traditionally built model began to develop horizontal cracks in the north and south walls and diagonal cracks starting from window corners in the east and west walls. In the quake-resistant model, because of the band, such cracks did not occur. By 10th shock, the northwest corner crack reached grade 4 level, with the west wall getting into the state of impending collapse. The band and the vertical reinforcement in the corner of the quake-resistant building prevented structural damage. In the 12th shock, the west wall collapsed and the roof began to tilt badly. The 13th shock fully destroyed the traditional structure. The quake-resistant structure stood up with only a few non-structural grade 2 cracks in the load wall on the top of the roof. The gable wall stood up because of the gable band. This test demonstrated that a stone house improperly built in cement mortar also can collapse, but a properly built stone house with all necessary disaster-resistant features is safer. The performance of the tiled roof can also be greatly improved. For ensuring safety, it is not necessary to build a structure with brick walls and a RCC roof supported on beams and columns.
So this experiment for the people who have actually witnessed here will give a lot of confidence and help them to adopt the technology, imbibe it and make it part of their construction activity.
જે મકાનો ધ્વસ્ત થઈ જાય કાચા મકાનો એની કમ્પેરેટિવમાં તો ઘણું મજબૂત છે અને પોતાનું જાન બચાવી શકે છે.
અમે જોયું એ પ્રમાણે હવે મજબૂતીકરણ મકાન બનાવવું પડે.
મજબૂતીકરણ મકાન બનાવવાથી ખૂબ ફાયદો થાય છે.
આ જે ઊભું છે એ મકાન બાંધવું જોઈએ.
2 ફૂટે યાદર મેકો ફરી ગયા લાંબો પાણો એટલે અમે ગામડામાં યાદર કહેવીએ ને એ મેકે તો ટકાઉ રહે કારણ કે એક દિવાલ પડી ન જાય. હુકમમાં ઘણા એવા કિસ્સા બન્યા છે કે એક કોઈની દિવાલ પડી જાય ને એક કોઈ નિયમમાં પડી કારણ કે કડું પાણા મેકેલા એના હિસાબે.
In Kutch, in the past decade, the use of cement concrete blocks has greatly increased because small stones used in these blocks are easily available. In the last earthquake, however, the concrete block houses also suffered severe damage. As a result, the people started using more expensive bricks instead of blocks since the earthquake. A shake table test was conducted to see the effect of earthquake on the concrete block houses.
In this test, we have 2 buildings, both having walls made of cement blocks and the roof consisting of reinforced cement concrete slab. This building on my right is built the way people make here, in which each wall is built one after the other. And the walls are cured for about 3 to 5 days. The second model here is a model of improved quality. The walls in this building are made using concrete blocks which have a depression, a groove in it, for improved connection between the blocks, improved bond between the blocks. And the walls were built all at the same time. The structure was cured for 15 days after the construction. In addition, for better earthquake resistance, vertical reinforcement has been installed in every corner With the help of blocks like these, which have what you call a keyhole, the vertical reinforcement continues up to the reinforced concrete slab and is bent into it and is connected to the reinforcement of the slab. In addition to this, there are also vertical bars adjacent on either side of the openings of windows and the doors to strengthen the openings. Also, to ensure better earthquake resistance, reinforced cement concrete band has been installed at the lintel level on all 4 walls.
Upon subjecting the models to shocks by tractor, the ordinary model started developing the diagonal cracks near the opening. After the 7th shock, all diagonal cracks widened to grade 3 level and the north wall above the door went out of plumb. In the earthquake-resistant house, such cracks did not develop. After the 8th shock, in the ordinary model, the roof slab slid on top of the wall and a horizontal crack appeared at their junction. After the 10th shock, the ordinary model collapsed totally. The improved model showed only the parapet separation crack of grade 2 level. One more shock of much higher intensity was given with a backhoe. The improved model survived even this shock without any further damage. The test effectively demonstrated that if the disaster-resistant features were incorporated in the construction and good quality could be maintained, the house built with concrete blocks having grooves in its top face could withstand the impact of an earthquake expected in the region. It is also important to tie the RCC roof with the walls. Mere use of 4 bars in the corners does not strengthen the building, and it costs a lot more.
I have a feeling this test can go a long way in reproducing earthquake-resistant behavior in models.
આના કરતાં થોડો ખર્ચ વધારે કરવામાં આવે તો આ મકાન સેફ રહી શકે છે.
મને લાગે છે કે આ રીતે બધા મકાનોમાં થવું જોઈએ.
સામાન્ય માણસને વિશ્વાસ પડે કે બહુ જ ઓછા ખર્ચના વધારાથી મકાન ભૂકંપરૂપ બની શકે છે.
જેને દિશા શરૂઆતથી સાચી મળે તેવા એન્જિનિયરો આગળ જઈને ભૂલ કરવાનો સ્કોપ રહેતો નથી.
એક સળિયો પ્લિન્થ બેન્ડ ગેબલ બેન્ડ આનાથી ચોક્કસપણે મજબૂતીકરણ અને ટકાઉ સસ્તું સરળ સાદું મકાન જે બનશે તે ગામવાળાને ફાયદારૂપ રહેશે.
અને કેટલાય ધક્કા માર્યા તોય પડતું નથી. આવું મકાનોને તો જાનહાની ઓછી થાય.
ગામમાં એ માલિકને પણ ખબર હોવી જોઈએ કે ના ખરેખર આ જે ટેકનોલોજી નવી છે એ પ્રમાણે આપણે બાંધકામ કરવું જોઈએ.
બીમ કોલમ કરતાં એક સરિયાવાળા મકાન વધુ મજબૂત હોય છે.
આપણે જે મકાન બનાવી છે એક સળિયાવાળો કોલમ જેને પ્લિન્થ લેવલ સાથે જોઈન્ટ કરવાનો, લિન્ટર લેવલ સાથે અને સ્લેબ લેવલ સાથે જો આટલું કરવામાં આવે તો લગભગ 10 થી 15% વધુ ખર્ચો લાગે અને મકાનની મજબૂતી જે આ બતાવ્યું એ પ્રમાણે ઘણી જ વધી જાય છે.
એક સળિયો પણ ઘણું મજબૂતી આપે કારણ કે ચારે છેડા જે પકડ થઈ જાય ને એ આખું મકાન બાંધી લે મજબૂત આમ.
After the last earthquake, many house owners demolished their slightly damaged houses and built new ones. Instead, with retrofitting, they could have made their existing houses more earthquake resistant. This would have cost them less than 15% of what they spent on the new houses. On the other hand, many carried out repairs in an unscientific manner and continued to live in them without knowing their high vulnerability. This could be reduced if the houses while getting repaired were also retrofitted. The objective of this test was to demonstrate the effectiveness of retrofitting of a traditional structure.
The first building on the right consists of a traditional building which is built in parts of North Gujarat as well as Kutchh. The house is made from stone in mud mortar and the roof on the top is a pitch roof made from Mangalore pattern tiles supported on timbered understructure. The house has been built by the local masons using locally available materials. This second house here is also a traditional house from parts of Kutch and North Gujarat. The walls of this house are also made using stone and mud, and the roof consists of Mangalore pattern roofing. But this house is retrofitted against any future earthquake. The basic retrofitting elements are, number one, the cast in situ concrete headers. These have been made by making holes at every specific interval in the walls, inserting a steel rod and filling it up with the concrete. The other retrofitting element consists of the seismic belt, which is made with weld wire mesh put all around. It's anchored to the wall and is plastered in cement mortar. A similar belt is also installed on the gable walls in a triangular manner, and that particular belt is connected to this bottom belt. One more important feature is the anchoring of the roof rafters to the belt in order to anchor down the roof structure to the walls. In addition, both the gables have been anchored using galvanized iron wires in the form of guy lines. And the last important retrofitting element is under the roof. It consists of diagonal ties in order to prevent the distortion in the roofing structure.
The test was a public event with more than 500 viewers from all parts of the quake-affected state. It included the government officials, the representatives of many NGOs and villagers, as well as masons from the villages all over. Upon being subjected to a series of shocks, the damage level reached grade 3, including some delamination, after 7 shocks in the non-retrofitted structure. In the retrofitted structure, the cast in situ bond elements prevented the delamination of the stone walls. The south wall of non-retrofitted house went out of plumb after the 9th shock. The retrofitted structure had no damage. After the 10th shock, northwest corner collapsed in the non-retrofitted structure. In the retrofitted building, the seismic belt prevented the walls from severely cracking and separating at the corners. After these 3 more shocks were given in quick succession. The non-retrofitted model collapsed after the last shock. In the retrofitted structure, a small portion adjacent to the door jamb collapsed. The rest of the structure stood up with mere grade 2 damage. The Mangalore tile roof also survived, since the rafters were anchored to the walls and the diagonal ties prevented roof from getting distorted and falling apart. This test gave confidence to the viewers that the retrofitting of an existing building prevents its collapse in an earthquake. They also saw the need to retrofit thousands of existing houses since they are vulnerable.
જે મકાનમાં રેટ્રોફિટિંગ કરેલું છે એમાં તિરાડ નથી પડી અને જે એમનેમ જ બનાવેલું છે એમાં તિરાડો જોવા મળી.
રેટ્રોફિટિંગ દ્વારા જે મકાનો બનાવવામાં આવે છે એને આજકાલના ઝટકા લાગે છે બહુ ઓછા લાગે છે.
કે આપણે જે આ સરિયા મેરીને બાંધેલો ખૂણા મારેલા રહ્યા એ થોડી મજબૂતી વધારે હશે અને પેલાની મજબૂતી ઓછી રહે.
જોયું એટલે આ સાબુત થઈ ગઈ વાત, સાબુત થઈ ગઈ કે નક્કી વાત છે એમ.
ચારે બાજુ પટ્ટો મારેલો છે ને એની મજબૂતી જોઈએ એમ, એ મજબૂતી રાખે છે અને ઓલો જે પટ્ટાવતરકનું છે એ તરત પડી જવાની શક્યતા રહે છે.
આવું પ્રેક્ટિકલી તમે એને દેખાડો કે આપણે અહીંયા સળીઓ નાખ્યો છે, અહીંયા આડી પટ્ટી, અહીંયા બેન્ડ નાખ્યા છે, તો સાદું મકાન જેટલી જલ્દીથી તૂટે એટલી જલ્દીથી આ મકાન નથી તૂટતું. તો આપણે થોડો વધારે ખર્ચો કરી અને આપણું ઘર અને જાન પણ બચાવી શકીએ તો એ વધારે સારી રીતે સમજી શકીએ.
Now the clear message was that in a very high intensity earthquake, such an improvement may not prevent cracking, but it will definitely prevent collapse. So people living in such houses will neither lose their life nor they will lose their properties which is there inside. The only action needed after the event will be to repair the damages, which could be done at a very small cost.
Field shake table tests showed to people that all types of well-built new houses having disaster-resistant features are stronger and safer than improperly built houses made of the same materials. It also showed that retrofitting does make an existing house safer. Use of such technologies could help the country save its scarce resources and reduce the miseries and hardships in future disasters.